When most people think of flooding, they picture rivers rising or coastal inundation because of a hurricane. But in Minnesota, the DNR estimates that 50% of all flood damages occur outside of mapped floodplains. The primary reason for this is extreme rainfall events. Now, when I say extreme, I don't just mean really big, I mean rare. In fact, there's a particular storm that engineers like to use, the 10-year storm, or a storm that has a 10% probability of occurring in any given year, so you see one about once every 10 years. These storms are important storms for evaluating stormwater infrastructure's behavior during these large events. However, as the avid Weather Channel viewers among you might know, these storms seem to be getting more and more frequent. Flooding in Duluth in 2012, the Twin Cities superstorm, the inundation of southeast Minnesota. It appears that these storms are becoming more frequent. But to get this from a gut feeling to something that is actionable, more analysis is needed. So that's where my research comes in. We looked at a large number of stations across the Midwest to answer this question. Because how do you study something that only occurs about once every 10 years? Even with 100 years of data, you'd only have about 10 data points. So we aggregate using over 1,200 stations with at least 70 years of weather data. We're able to produce results that indicate general trends for the region. We can normalize for geography because we have different rains in different plains, and then also normalize by the number of stations that actually are reporting in any given year. And the result is that we can track the occurrence of these storms. In a stationary climate, or one without climate change, we would expect behavior like the dashed red line, where there are about 10% of stations seeing a top 10% event in any given year. But what we see in the modern period differs pretty far from that. We're looking at more of a 14% occurrence. So your 10-year rainfall depth is now occurring about once every 7 years. And this trend, if it continues into the future, will become more and more pronounced. This sort of data is extremely useful, not just for engineers designing systems to withstand this, but also for other scientists who are modeling climate through global climate models and atmospheric circulation. It allows them to have a base point to reference for whether or not their models accurately reproduce historical results. So this way they are able to project even further into the future than a simple linear regression would allow. So using this, we can hopefully better understand what storms are in the stormwater pipeline.